Hey everybody. Thought I'd share a little video here about a radio project that I worked on a while back. What this is a one transistor regenerative receiver for the AM broadcast band. The sort of impetus for working on this project was that we have a day at our university where I work where we bring in students from high school, middle school, all the way down to elementary school, and show them different projects in different areas of engineering. And I thought I'd show a simple radio project, something that you could build at home with, Radio Shack components and, a few extra things that you get off of the web or from other places. And also because I was just interested in these regenerative receivers, and eventually I'd like to do a vacuum tube version, but this was quick and simple just to sort of demonstrate the principle to myself, I guess. So, right here is the actual transistor, the one transistor that makes the radio receiver. Over here is an LM386 audio amp, which just takes the very small amplitude signal that this one transistor produces when it receives the radio signal and amplifies it to something that we can actually hear on a speaker. The whole thing runs off of one 9-volt battery. I've got a hand-wound coil here and a tuning capacitor. Coil form is the classic, toilet paper tube. This is actually a part of a paper towel roll from like a, commercial grade paper towels, the rough brown paper towels. This is actually a little bit thicker cardboard than from a standard toilet paper roll, and so when you wind this 22 gauge magnet wire on it, it doesn't tend to collapse like the thinner cardboard on the toilet paper rolls does. A couple potentiometers down here for volume control and regeneration. And it's already powered up, so let's just go ahead and I'll turn up the volume and maybe you can hear some of it. So that whistle you just heard is when the radio goes into oscillation. If I get a little closer here, you can maybe actually hear the station that I'm tuned into. It's kind of faint. I've actually found out that if I take the whole radio and turn it on its side, the signal gets quite a bit louder.
Answer your questions toll free at 888-83-FUNDS. That's 888-83-FUNDS.
So maybe I should have mounted that coil horizontally. Works a little better outside, actually, when you're not surrounded by your interference from computers and everything else you have around. Just set it up again. I'll try and tune around and get some different stations just to show you how the tuning works. But you have the regeneration control right here, which is sort of like the gain of that transistor circuit. And as you tune for different stations, and let me get the volume and everything set just right here. But as you tune for different stations,
you can visit
it's not a lot going on right now because it's early morning and it's hard to get good reception.
Last text I got from you, I'm looking at my phone right now, came on May 14th.
This works really well at night when there's not the solar interference.
No, I wouldn't delete it. No, hey, trust me, I'm responding to text.
So the way the tuning works is you get a station, or you get close to a station. And then you adjust this regeneration control. So if you turn it down, station gets weaker, fades out. Turn it back up. And eventually it starts to whistle like that. So the goal is you want to get it as close to that whistling stage, that oscillation point, and then tune it and turn it back just a little bit below that. So that station's tuned in pretty good right now. and then I can adjust the volume. Just a simple point-to-point wiring underneath here. This is just a piece of that prototype board like you can get from Radio Shack or anywhere else. Nothing special. All the components are on the top except for these 3 diodes down here, and I'll explain those in a second why they're there. As I pointed out, the tuning coil and capacitor and all the goodies in here, if I can get a good picture of those. But a lot of filter capacitors around this audio amp because you get sort of, I guess, maybe you call them subharmonics or whatnot that come from the RF and from the oscillation of this transistor when you get near that regeneration, that oscillation point. Kind of went overkill here. I had a silver mica capacitor sitting around, so I actually put a silver mica cap in this thing. It's definitely overkill for what this gadget is. But, hey, why not? Some old school looking carbon resistors there that I had lying around. 1 tantalum capacitor, and then just some regular old electrolytics for filtering this audio amp. Now, the reason for those 3 diodes underneath was that when I originally built this, I was going off of a design that I found online. So, as you so often do, I decided I wanted to build one of these 1 transistor radios. I Googled for a schematic, and I came up with this schematic, which is a pretty simple design. You got your 1 transistor right there, your audio amp over here, and here's the address of that if you're interested in looking it up. And the guy's got some basic instructions down here how to operate it, what voltages to run it off of, and so on, and how many turns to put on different size coil forms, and so on and so forth. Well, I wanted to kind of get the original source of this because he had down here that this came out of Electronics Now from July 1997. So I went over to our university library and looked around, and guess what? We actually had that issue of Electronics Now. And here's the original article and the original schematic. And notice the original schematic here does not feature that LM386 audio amp. So on the far right there where it says audio out, the intention is that you hook up something like high impedance headphones or a crystal earpiece. I wanted to gear this towards something that students could easily build, kids could build very easily. Didn't need any weird components. So high impedance headphones and crystal earpieces are a little bit weird, hard to come by. I have a pair of high impedance headphones, I snagged off eBay a long time ago, but most kids don't want to have to fool with getting stuff like that. So the nice thing about this design is that it does use the LM386 audio amp, and you can just plug a standard 8-ohm speaker into it, or standard earbud, or whatever you have on hand. So going back into this design, you'll notice that for the biasing network on the transistor, we just have a simple resistor divider, which is okay if your supply voltage is very stable. But in this case, because this transistor is going into oscillation, we could be running off of this says 6-volt battery. The original article said a 9-volt battery. So there's all this potential variation in what this bias voltage on this transistor can be. So I had a lot of trouble with this circuit when I first built it. It would just sit there and squeal constantly. Couldn't get any stations in at all. And I fiddled around with it, and I eventually found a set of 4 AA batteries that managed to get the base at the right bias voltage so that it didn't sit there and just squeal constantly. But I thought that's also not very convenient for people who actually want to build this circuit and have it work without having to fool around with it too much. So I did some more research on these regenerative 1 transistor receivers, and eventually came up with another article, this Simple Regen for Beginners, and actually found a number of articles by this author, Charles Kitchen. And this dude is sort of like, I don't know, the god of regenerative receivers or something. But he's got a ton of articles around in the ham radio magazines and different electronics magazines online. So I looked at a couple of his designs, including this one here. And the crucial thing I noticed with his designs, all of them, is that for the base of his transistor, he always uses 3 diodes to ground, like this. And quite obviously he's clamping that base voltage using the series diode connections, so you have a nice constant voltage there at the base of your transistor. So what I did was I went back and modified my design, which I'll show you just now. So here's actually the schematic for my design. And I just went in, and where this resistor divider network was in the original design, I just put 3 diodes across that bottom resistor. And that actually solved all of my weird oscillation problems where the thing would sit there and not pick up any stations and just oscillate constantly. This seems to work pretty well regardless of supply voltage. You know, in my case I'm using 9 volts, but you know, you could easily use 6 volts or whatever you have on hand. So that pretty much took care of that oscillation problem. And now the radio is functional, if somewhat quiet, depending on how it's oriented.
The clover representing luck and the rose representing love.
Of course, very sensitive to hand capacitance, and if you touch it at all, you get that 60 hertz hum, buzz. So that's the radio, and that's pretty much how it works. Not super happy with this performance-wise, just because you know it is so touchy, and even after I've fixed the oscillation problem, it's still pretty touchy, and not very good at picking up you know, even slightly weak stations, whereas a standard radio has no problems at all. So what I've decided to do, the reason I'm making this video is I'm very shortly going to destroy this radio. I'm going to rip it apart and turn it into something else. I'm going to reuse the coil and the capacitor and turn it into a new project. But I thought I'd just go ahead and show this circuit as is, and how it works and how it doesn't work very well. And if I am going to revisit this at some point in the future, I will almost certainly build this design from Mr. Kitchen, this simple regen for beginners. This one actually, you know, picks up the shortwave bands and the ham radio bands, so it's going to be, you know, more interesting listening. This is just standard, plain old AM radio, and you know, there's not much on AM radio anymore. Even if you run your own transmitter, you know, you can play music, but who wants to listen to music on a tiny little speaker like this? So, yeah, I'm going to tear this one apart, rebuild it into something else, and down the road someday maybe I'll build a new regenerative receiver. But if you're looking for a schematic, something that we want to build a regenerative radio from, you know, this design works, but it needs some modifications. If I had to make a recommendation, I would say this design, which I'll show you the link for this up here. You can get this free. It's just on one of the ham radio websites, actually from the ARRL. So check it out, and I think I'll just finish up here, and that's my one transistor regenerative receiver. What's left of it, shortly to be destroyed, probably for an AM transmitter. Reuse the tuning coil as the sort of filter for a simple transmitter. Okay, well, see you guys later.